Weathering is the breakdown of rock. It can refer to things as large as mountains breaking apart, or as small as a pebble being chipped. Regardless of the scale, though, it refers to rock breaking into smaller pieces or chemically changing into something new. It can occur by either physical or chemical processes and is split into two types, based on which type of process drives it. Mechanical weathering is driven by physical processes, and chemical weathering is driven by chemical processes. The names are similar to how mechanical digestion refers to your teeth grinding food into smaller pieces, and chemical digestion breaking food down through a series of chemical reactions with compounds in saliva and the fluid in your stomach. Just here, we're referring to rock and the process working around them instead of food. During mechanical weathering, rock is broken down into smaller pieces by another object or material, but its chemical properties do not change. Think of a wrecking ball smashing a brick building for a blatantly obvious example. In nature, a variety of things can cause mechanical weathering. Animals digging in the soil or sand, or just walking around on top of it, can cause rock particles to break or crack. Similarly, the growing root and shoot systems of plants can reach into existing cracks in rocks and cause them to expand, eventually causing the rock to break. Outside of the impact of living things, rocks being blown about by wind, carried by water, kicked by animals, or falling because of gravity can impact other rocks and cause them to break down. This grinding away of rock by other rocks is called abrasion. A recognizable example of this would be rocks at the beach. They're usually smoother because they're constantly beaten and abraded by sand and small rock particles. Ice can also cause mechanical weathering. A property of water is that it increases in volume when transitioning from a liquid to a solid state. If water seeps into a crack in rock and then freezes, this increase in volume will apply pressure to the inside of the rock and cause it to split apart. This process, in which ice slowly expands in rock, is called ice wedging. Even if noticeable cracks in rock do not exist, the ultimate freezing and thawing of water around rock can weaken it and ultimately cause it to weather. Potholes appear on the road every winter because of this frost action. Rocks are generally mixtures of multiple compounds rather than pure substances, so a wide range of chemical reactions can cause them to change their chemical composition. When interactions with the environment cause the different minerals in the mixture to separate or change, chemical weathering has taken place. Interactions with the air, water, groundwater, acid precipitation, and organisms can all introduce chemical components capable of causing chemical reactions in rock and driving chemical weathering. The constant presence of water can cause rock to weather, which is why once flat rocks or driveways often develop slight indents where puddles form. Acid precipitation, which has increased because of pollution, can exaggerate these effects and often leaves more visible signs. Anyone who's ever seen an outdoor statue discolored in the areas most exposed to the rain has seen the effects of acid precipitation. Under the ground, water has even more potential to interact with corrosive chemicals. Weathering by groundwater or soft rock underground explains why caverns filled with stalactites and stalagmites form. Also, the air, similar to the rocks themselves, is a mixture of multiple compounds with the potential to react with the compounds in rock and cause chemical weathering. Rusting is just one example of such chemical weathering. Finally, living things such as plants, animals, algae, fungi, and bacteria all secrete acidic and basic compounds capable of weathering rock. Weathering, whether you're referring to mechanical or chemical weathering, doesn't always occur at the same rate. Dynamite will break rock a lot faster than the abrasive powers of a quiet stream, and much faster than the chemical effects of a puddle. When looking at how fast rock will weather, several things must be considered. The first is the cause of the weathering. Are we dealing with acid rain, abrasion, a person digging in the backyard, etc.? The second is the type of rock being weathered. Some types of rock are softer and more vulnerable to weathering than others. This is called differential weathering, and it accounts for the unusual shapes some large rocks, megaliths, naturally assume. The softer parts of the rock weather down, leaving the harder rock behind. The third thing to look at is the shape and size of the rock. Rocks with large surface areas have more room to come in contact with weathering agents than similarly composed rocks with smaller surface areas, and as a result, they weather faster. A pile of gravel has much more surface area than a boulder of similar mass, so it could be weathered down to sand much faster. Climate can also affect the rate of weathering. Chemical reactions work faster when energy is added, so they go faster in warm environments than cool ones. As a result, chemical weathering takes place faster in warm climates. Since constant changes in temperature can increase the ability of ice to mechanically weather an area, places with highly variable temperatures also experience high rates of weathering. Also, since water is such a major weathering agent, areas exposed to water have higher rates of weathering than dry places. Altogether, warm, wet places, or wet places with variable temperatures, have much higher weathering rates than cool, dry places. The peaks of mountains weather more quickly than at bases because they are exposed to more wind, water, and temperature changes. The speed at which water runs down mountain streams compared to the fields and forests below also increases this difference.